Let's unravel some of the player controls in this project. First, let's recap how they work, and I'll talk a little bit more about what's going on here. Of course, we see that the player is rotating to follow the mouse. This is a relative position, meaning it's just the character following wherever the mouse is on the screen. Now, this is actually a little bit more complicated than it might seem at first, because we actually have to be aware of the camera perspective when doing this calculation. I'll explain that shortly. We also have back and forth, up and down movements that we can combine together for different angles. And this is a global movement perspective, meaning I don't care which way I'm facing. Left and right are always going to go the same left and right relative to the world. So this type of movement, world related. This type of movement, character related. And we'll see how we accomplish both those kind of breakdowns of movement when we dive into the script. Our player movement script. Notice really quick that it's attached at the base layer of the hierarchy. Everything underneath it, the eye, the iris, the behind, are all going to follow along with the behaviors of this parent object. Let's dive in. We set a speed like normal, and then I'm going to have some code, some variables set for the mouse that we'll talk about later. A vector 3 for the position of the mouse, some information or a reference to the game's camera, and then a couple floats here that I'm going to be using later to store some data that I'll talk about down below. Next, we're going to be using a method this time called fixed update. Up until this point in time, we've used the method just update. So when I pull an update here, this method runs every single frame. What's the difference between fixed update and update? Well, the main difference is update, and I'm actually going to write a little comment into the side here. Update runs once per frame, whereas fixed update runs once per predetermined time frame. Meaning that if your frame rate is quite low, maybe you're only getting 30 frames per second, the fixed update might still run 60 times per second, meaning it will run in between the update. It'll run twice for every update that it runs. This is frame rate independent, and it's used for physics calculations so that the physics doesn't get weirdly calculated when there's disjointed frames and other things going on. So anytime we're interacting with the physics system, we want to be using fixed update. It's a little bit less efficient, but it's needed for such calculations. And so we're going to start to implement it in some cases here. I'll get rid of this update for now. In our fixed update, we're running our two main methods here. Let's dive into the first one, our mouse turning. Now, we're first gathering what we call our mouse vector. We're building a new vector 3 based off some information. And you'll see that I actually have a reference to my mouse position on the screen, the mouse X and the mouse Y in particular here. Now, the Z axis is the thing that's a little bit strange here because the camera is needed when we do this type of calculation. What's happening here is that wherever the mouse is positioned on my screen, I want to know the X and Y coordinates in the world where that mouse is hovering over. But the Z coordinate, which is going to be determining some of our depth, is going to be based off of the camera position. And this near clip plane actually tells us how far away the camera is from the plane that I'm examining. So it's going to actually help do a proper calculation of the depth away from the camera. If that doesn't make a ton of sense right now, that's all right. We'll keep on exploring it, and for now you can just use this to whatever effect you're able to. And the next thing I need to do is actually assign a value to my mouse position, this other vector 3 that I'm storing as a variable. And what I'm going to be doing is accessing the camera and getting what we call a screen to world point. Now, this is going to be based off of this vector. The screen to world point is what, well, it says here in the comment, transforms position from screen space into world space. Our perspective from the camera is relative to wherever the camera might be. And the world changes depending on our view. I think the best way I could explain this for now is if we actually have our camera selected, you can see the perspective of the camera itself being presented. But as I move, that perspective shifts and it overlaps with different coordinates because of my relative perspective. And so the way that physics actually determines where is my mouse, it kind of depends on kind of how far or away I am from that plane, how far to the left or right I am. All my relative positions matter. But when I'm running in my game, I'm looking at the world through my camera. So I have this constant perspective that each frame I need to kind of be updated on how the physics engine needs to interpret the position of the mouse based off of that kind of subjective perspective. And so I'm taking in this position that I've gathered from all this information, and I'm doing this conversion that luckily for us is done behind the scenes to get the actual final mouse position. A long-winded way of successfully getting that, but this is the way that we need to work with mouse position in a 3D space. Of course, if you make a 2D game, the mouse position is going to be a much simpler calculation. This is one of the spaces where our 3D realm causes us some headaches. Okay, let's continue. I now need to define a new rotation. And I'm going to use this quaternion thing again, the thing that's responsible for dealing with the messiness of rotations. The quaternion has a function or a method here called look rotation. This creates a rotation with the specified forward and upward directions. So I am going to be basically creating a rotation based off of the mouse position minus the character's position. And then I'm going to be applying something called Euler Angles. We still haven't talked in detail about quaternions. I think we're going to save that for quite late in our course. But for now, we need to know just the basics of what's going on here. So our mouse position that we've determined, some coordinate in vector space, and then we also know our player position. And by doing this math, mouse minus transform position, I now actually have an angle calculated here that's going to determine behind the scenes what rotation is needed to get it facing that way. So if I have my mouse over here, the character needs to know that its position and the mouse's position, there's some calculation that goes on by the difference in their positions and this function look rotation that applies an angle that becomes a rotation. The reality here, though, is that we don't want our object rotating in kind of strange ways. One of the problems that we have is that the mouse, it's kind of hard to know exactly where it is in all the dimensions of space. So as I move it around the plane, like what's the y depth that I'm looking for here? Is it the x, y, and z, not all the coordinates are perfectly defined. And when we think about rotations, let me pull up my player here and look at my rotation schema. For the player to be turning around backwards, if I zoom in here, I see it's this kind of green line that we're rotating with. What axis of rotation is this? Well, of course, I can look up in my inspector and see that it is the y axis that is being rotated around. Make sure you make sense of that. Think of like a vertical line through the center that this is rotating around. The other axes are rotating around different dimensions, although I've limited, sorry, I clicked here, how much it can do at once, but we are actually needing to affect only the y rotation. Any other information gathered by the mouse that might not be 0, 0 is only going to cause our object to like rotate in weird ways that we don't want. So what I'm doing here is I'm limiting the rotation to not happening at all in the x and z axes. I'm only allowing the rotation to happen in the y. So I've calculated this complex angle that's going to apply some rotation, but before I actually apply it, I'm just saying, hey, actually, I don't want you to rotate x and z at all. Leave those alone. The y, however, is unchanged from the original calculation, meaning that when I actually set my rotation to this new rotation, it's going to capture the data from my camera perspective, do those calculations to figure out what angle is needed to match this difference in position, and then it's only going to apply that y rotation so that my object turns in the way that I want. And of course, if I wanted other types of rotations, I could remove these lines and leave it as what was calculated, but I assure you, if you do so in this context, you're going to have some strange results. In my view, mouse turning is probably the most complicated thing that we've done yet in terms of our player management. And so I've definitely provided you with this script so you can work with it. What I'm trying to do through these tutorials is giving you in each section a different perspective on player control. And hopefully one of the ones that we use is close enough to what you want to use in your game that you can just borrow my code and tweak it to fit your actual design goals. If it turns out that you need the mouse to behave in a very different way than we've worked with in any of our tutorials, well, in our deep focus section, you can always dive into some more research or ask for some assistance in your design decision. For now, let's move on to keyboard, where we had this universal world style movement. Like normal, I gather my inputs, and what I'm going to be doing is determining a right and up moving vector. I'm splitting these up. So this is like the horizontal, and this is the vertical vector. And with this, I'm I'm making a new vector 3 based off of the actual input times speed times time delta time with 0, 0 afterwards. This means that I'm actually only changing the x values. The y and z are going to be remaining unchanged because, well, back in my world here, I want the x coordinates to have this moving left and right. And then for my moving up, well, in my world, that's the z-axis, so I should be seeing all my data in the z-axis on my new vector 3, with x and y being zeroed. Perfect, so I split these up into 2 separate vectors. And now what I need to do is actually translate moving right, and translate moving up. However, in the way that we may have used this before, we just put this move in directly, which does work if we're not rotating our character. Let me show you something here. If I take out that extra bit of information, that space.world thing, and I go in and rotate, and then I try to move left and right, it's going to move left and right relative to my rotation, which maybe is a control scheme that you want, but it's not what I wanted for this experience. It kind of feels really difficult to control. And so what I need to do is have this code in. The second entry in this constructor, or in this method call here, it's just a method, is space.world. And there's some other options in here that we can take a quick peek at here. Under space, self transformation relative to the local coordinate system. That's basically what happens if we don't write anything here. But we can also manually state it if we want to change it around later on. Space.world means actually translate it based off of the world coordinates. So our actual x and z positions are world relative rather than object relative, giving us the flexibility to have the controls work in exactly the way that we'd like. And so, one more time, our mouse is tracking. Oh, I clicked my little laser by accident there. Spinning around, calculating these angles automatically with those quaternions and Euler angles and other things like that. And then our global coordinates are being mapped out for our movement for a very different control schema that's kind of complicated, but at the end of the day, easily borrowable from my scripts or other ones online to make a very different type of feeling game. See you in the next video.